Good day, guys. You're welcome back to ID Mathematics Academy. Today we are going to consider indices. The word indices is a plural form of it. The plural form is indices, which means powers or exponents. The singular form of it is index, which means power in the singular form or exponent in the singular form. So, what do we mean by indices? When you have number like 2, in index form, it will be 2 raised to power 1. 3 in index form will be 3 raised to power 1. 4 in index form will be 2 raised to power 2. 8 in index form will be 2 raised to power 3. And 32, just to list but few, 32 will be 2 raised to power 5, and so forth. But in indices, we deal not only with whole number, like 2, 3, 4, 8, 32, we can also deal with fraction, where we have 1 over 2, 1 over 4, 1 over 8, 1 over 32, and so forth. How do we express this in index form? There is a general law in indices. The law is 1 over x. It means x raised to power negative 1 in index form. According to this law, 1 over 2 will be 2 raised to power negative 1. According to that same law, we can express this as 1 over 2 raised to power 2. Don't forget, 4 is 2 raised to power 2, as we have seen it here. Now, finally, you can now refer to this as 2 raised to power negative 2. What does that connote? Whenever you have 1 over anything, and you wish to remove the 1 on top, then negativity will be introduced to the power of the denominator. The power of this denominator here is 2, which is positive. Negativity will be introduced to that power to make it become negative power 2 when we remove the 1 on top. Also, this will be 1 over 2 raised to power 3. We first raise 8 in power in index form. Then we now re-express this as 2 raised to power negative 3. And finally, we have 1 over 2 raised to power 5, which is finally expressed as 2 raised to power negative 5. So this is the idea of indices. This is what we mean by indices. It's just the word indices is the plural form of it. We are dealing with raising numbers and powers in index form. That is what we are busy doing inside the topic indices. So when you are faced with any question in indices, let it first come to your brain that you want to raise the number in index form. Now we come to laws of indices. The first law we are considering is multiplication law of indices. And I will explain this law by examples. Example 1. Simplify x raised to power 3 times x raised to power 2. When question comes like this, there are 2 methods available for you to employ. You may decide to go by the way of expansion method. In the expansion method, you turn x raised to power 3 times x raised to power 2 to x times x times x, that is for x raised to power 3, that means x in 3 places, times x raised to power 2. X raised to power 2 means x times x, that is x in 2 places. We've expanded everything by expansion method, which means count the number of times you have the x. 1, 2, 3, 4, 5. That means x raised to power 5. X raised to power 5 is the answer just by expansion method. Another method is adding indices. The method of adding indices. I bring the question down, x raised to power 3 times x raised to power 2. Originally, the law of multiplication states that the multiplication sign that serves as the operation between 2 or more terms there changes to addition in the exponential region, in the power area, power region, and it adds the powers together on only one chosen base. Since the bases are the same, we choose only one. That is, one of these bases, choose it. Since they are the same, I choose one. Now the power on this we add to the power on the other. Do you understand? The addition sign that is adding the powers together is gotten from the multiplication. It is the multiplication that changes to that addition in the exponential region. So we now have x raised to power 3 plus 2, that is 5. That's the answer. You can see that the two answers, they are the same, but by two different means. Example 2. Simplify 2y times 8y raised to power 3. Yes, you can use either expansion method or addition of indices method. So let me use expansion method first. 2y times 8y raised to power 3 means 2 times 8. I separate the figure first. Times y times the y raised to power 3, I break it into its segment. Y times y times y, that is y in 3 places. So this will be 2 times 8, 16, times y in how many places is this? 1, 2, 3, 4. Y raised to power 4 times 16. Answer is 16 y raised to power 4. Or if you choose to use the other method, that is simplifying it by adding the indices. So we have 2y times 8y raised to power 3. In this, you first separate the figures. 2 times 8 times y raised to power 1. When you see a variable without power, power 1 is on it. Variable y is without power, power 1 is on it. So make it feasible. Times y raised to power 3. 2 times 8 gives 16 times. Here now, you now choose one of the bases. I choose 1. So change the multiplication to addition in the exponential region. That is, when it turns to addition, it will not stay here on the floor. It will get up to add power 1 and 3 together. So it becomes 1 plus 3. Do you understand? So we have 16 times y raised to power 4, because 1 plus 3 is 4. And finally, you have 16y raised to power 4. You can see that the answers are the same. So those are the two available means of simplifying these in indices. Let's consider this example 3. Simplify 2 times 10 raised to the power 3 times 7 times 10 raised to the power 4. Using expansion method, I write 2 times 10 raised to the power 3 times 7 times 10 raised to the power 4, which means 2 times 7, those special figures, times 10, times 10, times 10, that is 10 in 3 places, times another 10 in 4 places, 10 times 10 times 10 times 10, which is 2 times 7, 14, times, you now write 10 in how many places? 1, 2, 3, 4, 5, 6, 7. You see, 10 raised to the power 7. That is 10 in 7 places. And that is all using expansion method. If you want to use the method of adding the indices, then you have this, or 2 times 10 raised to the power 3 times 7 times 10 raised to the power 4. This means 2 times 7 times 10 raised to the power 3 times 10 raised to the power 4. 2 times 7 is 14 times 10 raised to the power 3 plus 4. Don't forget that the multiplication sign there will change to addition, and that addition will be lifted up to operate the powers up. So that addition will now come up to add 3 and 4 together, giving us 14 times 10 raised to the power 7. You can see that the answers are always the same. Let's consider example 4. Simplify 4x times 5xk. By expansion method, 4x times 5xk is 4 times 5 times x times this x in 2 places means x times x. So we have 20 times x, 1, 2, 3 raised to power 3. So we have 20x raised to power 3. That is the simplification using expansion method. But what of when we use addition of indices method? We have 4x times 5xk to be equal to 4 times 5 times x raised to power 1. At this juncture, you have to indicate that the power of x here is 1. Once it is invisible, once it seems there is no power on a particular variable, then power 1 is there. You now have to make it visible. Times x raised to power 2. 4 times 5 is 20 times x raised to power 1 plus 2. You add the powers together. So this will be 20x raised to power 3. I want to believe you understand it perfectly, and that is that about that. Let's consider example 5. Simplify the following. Here, 3y raised to power 5 times 7y raised to power 11. In the exam, actually, except in textbook, no exam will demand a particular method from you in indices. No exam will say simplify using expansion method. No exam will tell you that. Simplify using addition of indices method. No exam will ask for it. It is only in the textbook you will find use this, use that, as far as indices is concerned. Therefore, when you see it in the exam, a question like question 5A here, you don't attempt at all to use expansion method because it will occupy the space unnecessarily. See, before you write y in 11 places, you now write y in 5 places. It will occupy the whole sheet. and it will not make any sense. Therefore, when you see a question that has greater power than necessary, then use the addition of indices method. That is, this means 3 times 7 times y raised to power 5 times y raised to power 11. 3 times 7 is 21 times, you now apply the law of multiplication here, which states that the multiplication changes to addition in the exponential region to add up the powers on a choosing base. I choose one of the common bases, so I now have 5 plus 11, so which is 21y raised to power 16. Do you understand? So that is that for question A. For question B, p raised to power 8 times p actually means p raised to power 8 times p raised to power 1. That p that is without power is actually having power 1. When a variable does not have a power or any power, it has power 1. So you now indicate that power 1. You move further by applying the law of indices. Choose one of the common bases. Now add up the two powers on that only one chosen base, and you have p raised to power 9. And that is that. Let's consider this example 6. Simplify 10 raised to power 3 times 2 times 10. Then we have 2 times 10 raised to power 3 times 10 raised to power 1. You indicate the power 1 on that 10. So which is 2 times 10 raised to power 3 plus 1. 2 times 10 raised to power 4. And that is it. Let's consider this last example on multiplication. Simplify 2 over 3 in bracket times 2 over 3 in bracket raised to power 3. 2 over 3 in this case is a fraction, and that fraction is the base number. So you can now rewrite it as 2 over 3 in brackets raised to power 1 times 2 over 3 in brackets raised to power 3. So you choose one of these common bases. 2 over 3 as the root number is common. So you put 2 over 3 raised to power 1 plus 3, which is 2 over 3 raised to power 4. Or if in the option, let's say you are working in the objective, this could be left as your answer. Or you now expand it back as 2 raised to power 4 over 3 raised to power 4, which is 2 raised to power 4 is 16. 3 raised to power 4 is 81. And that is the final answer. Now, I want to engage you with these questions before we continue. I've been teaching you for quite some minutes now. You to do this for me. I'm waiting.